Okay, so this will be the last piece of the session video. I'll work a few problems and we'll call it done. So the first problem is problem 1011. The file has been provided to you. I've opened up the data already. And here's what it looks like. And the problem says it has annual observations of the American minimum wage, has the minimum wage growing at a constant rate over the period. Use simple linear regression to address this question and explain the results. Okay? So how do we do that? Pretty simple, since it's simple. One thing is a good practice, make sure your, until we get multiple regression, it doesn't really apply, but I always like to have my dependent variable on the outside, my independence on the inside. But for this, we're not going to be predicting inflation. We're just going to be predicting minimum wage, right? So the way you do that, go to data, come over here to data analysis, regression, click OK. I'm just going to delete it out. And so let's go to the dependent variable wage. We're trying to predict wage. Shift, control down arrow. The X or independent predictor. Okay, we're going to create a new sheet. Look at the residuals and OK. And here's what we got. So let's right click. So it's easier to follow. And here's what we've got. Okay, so it looks like their R squared is 96. Adjusted's not too far from it. How accurate of a predictor is year? Well, looks pretty accurate, right? So if we're at the negative or on our exponent, right? It's a lot of zeros in front of us, so it's extremely accurate. And how do we explain this? So for a year, a unit increase in year plays roughly what? So think about this. What are we predicting? Right? What are we predicting? Minimum wage. So it's about 10 cents. So one unit increase in year plays a role of increasing minimum wage about 10 cents. That's how we interpret this. Okay. We could do a scatter plot. Okay, so we could click here and kind of look at our data. Insert. Look at the residuals, how they're kind of flowing. May give us a little concern to start looking at a pattern like that. Let's look at our error. Not too bad. Other things that we could do, this is you would sort your data and then we would come look at the predicted. Right? So let me show you. Just go back here. Create copy. And on this case, we want to sort. Okay, we're sort here, so that'd be fine. Yeah. I'm thinking of the next example where we'd come back and sort, but no, this is fine. So this is really just high level, doing a simple regression. The standard error doesn't look too bad. We have significance. It's really low, right? Look at that standard error. Okay. So we're pretty much done. For the interpretation, how we explain the results, year plays a role, right? And what is the regression equation for this? Y equals minus 195.76811 times your new predicted year times that. Okay, so for 2007, we would project equal minus 195.76811 plus just point it to it, plus times 2008. So we would project 5.70. Gotta go back. Okay. So we say, well, that's less than 2007. It is, but that's the way the algorithm works. That's the way our equation has calculated. All these 0.15s are playing a role in smoothing it. Okay. So, all right. Next one. Okay, so go to page 441. So let's look at enrollment. And it tells us, in particular, this is our DV, and then it said, and the following explanatory, we'll get it out. Portion of female students, percent. Here's an IV. Portion of minority students, and portion of international students. And we're trying to see if there's any type of relationship, right? Here's something that you could do very easily on the front end, right? We're gonna make some copies. So this is where I was telling you I would put either my DV on the far one side. It would relatively work in here. We'd want to move our minority over because we're not going to look at percent of Asian American. Let's do that now. And the only reason I'm doing this is when we load our independent variables for multi-regression, as we're shifting gears, we'll want to keep all these together and keep our dependent variables separate. Okay. So I want to show you a neat little trick to kind of get a feel of the data. Control C. It's a little far. Okay. So one thing that we can do to kind of get a glimpse of a scatter plot, it's how you align these is really important too, right? So if we want to look at percent minority and enrollment, we select both columns like so. And let's go over here to insert and a scatter plot. We could see what our grouping looks like, right? So that's telling us one story. And here's our last one that we'll look at. So we can kind of see, do we have a relative linear relationship going on? So we're kind of reviewing data now before we even run a regression on it, as we look at these data points, right? This has got the fan shape that's going to it's given some concern on the front end. This doesn't show us too much of linearity, right? I should have put labels on it. My apologies. And this is female. And this right here is minority. So when we look at these scatter plots, we're, like I said, it's kind of giving us a little bit of a glimpse to get ready for what's to come. Okay. Shifting gears, let's run a regression. Let's see what the data says. Data analysis, regression. Because we're trying to predict enrollment. And now we're going to pick up our groupings. Oh. So let's see if we have some missing values. Let's see here. So when we have missing data, there's a couple of options that we have available to us. We can impute, which Excel does not have the ability to do that. We can interpolate, which is similar, like we take the mean. We can, it's called listwise. It's called listwise deletion, which that means you remove the record in entirety. We could use an algorithm that Excel doesn't have. This is where R and others, I'm telling you the things you're like, well, tell us what we can do, right? But we finished that thought. So the other one's called FIML. It's an algorithm. It's called Full Information Maximum Likelihood. That is, we can use that as a mechanism to adjust for missing data. So it poses a little bit of an issue when we have missing data. Let's see how many data points we have missing for the percent minority. Okay. So we have a completely missing row right here. So that will be grounds to remove. Another one. It may run with two, because we've got some data points. When you start dealing with missing data, it gets into the world of, is it missing completely at random? So it's called MCAR. And there's a few rules. The guy that wrote the book literally on it, his name is Todd Little. He's from Texas Tech. And so he has kind of pioneered that world, how we adjust and deal with missing data. I want to see if Excel will run with two missing data points just for one independent. If it does, great. If not, that means we'll do a list-wise deletion and we'll just remove mine in entirety. It was okay to remove those other two records because there wasn't even a dependent variable. Okay, so let's try this again. Data analysis, regression. Only reason I'm deleting out and reselecting in case it had empty rows down there. Okay. And then we got our independence. Yep, so it's not going to allow it to run. The only way that we would be able to get this to run would be to strike it out or take the mean. So we can interpolate. Okay. I'm going to go the list-wise deletion route. And enrollment. And X values. Okay. So again, that's called list-wise deletion when you remove out all of your record data. Okay. Typically, we account for, if you have enough data, the threshold's about 120 data points. Okay. 120 data points, you have stronger argument to use some of the other tools. Imputation, FEML, transformation. Okay. All right, so if we look at this, I told you it looked like there's a little bit of noise when we looked at the preliminary data, right? Here's my charts. Oh, this is on the other one, sorry. Okay. Oh, it was here. Getting goofy. If you remember our charts, I told you that there were some fans on the scatter plots. That gave a little bit of concern. So we can see here we got p-values aren't fitting and being very predictive of percent of international, female, or minority to play a role in predicting enrollment. Okay. And so we can extrapolate that. What's the R square? It's terrible. This shouldn't surprise us, though. We already got a preview by looking at the scatter plots, right? Which were essentially correlations. Okay. Okay, look at the error. Look at that. So we got standard error. We got our coefficient in this ratio is really high. Okay. So in this case, after removing the data, I don't think that they would have made that much difference. Potentially on the international, but not enough for removing 2 data points to bump these to significant. And especially looking at the R square, this model's not very predictive. So that's our interpretation here. So let's close this out and let's get into the case and then we'll call it good for the night. Anybody can guess what ski resort that is? Survey says
If you said Steamboat, Colorado, you are correct. All right, here we go. Get this out of our way. I've already got our formulas because we're going to have to put formulas in here. If we look at the case, it's on page 470. And it's asking first, do buyers pay a premium for a brick house, all else being equal, right? So let me bring in some formulas. This is the if statements, right? So the way this reads, if it's brick, and if E2 okay, so I'm going to copy and paste some formulas in to kind of expedite this. And I'll walk you through how to interpret them. So in this particular formula, we're pulling in because the yes means it's a 1. So this is our binary. We're turning on the variable or turning it off, right? So if it's brick, yes. And so it's going to point over here. If we go over here to E2. If it says no, it's a 0. If it says yes, it's a 1. Okay. Here, so we're looking for number of bedrooms. Okay, right? So, or neighborhood, sorry. So is it neighborhood 2 or 3? And so if it's in neighborhood 2, it's a 1. If it's in 1, it's a 0. If it's in 3, it's a 0. So we're turning this variable on and off. Same thing here. Okay. If it's in neighborhood 3, it's a 1. Otherwise, it's a 0. And this is kind of adding in, is it brick in neighborhood 2? Brick in neighborhood 3. Okay. So we could look here. Is it neighborhood 3? Yes. And is it brick? Yes. So neighborhood 3, brick, equals a 1. So we've essentially turned on variables with if statements. There's a couple ways that we could have got here. I can show you these in class. I'll take some time to copy and paste just to kind of show you what it looks like. Control C. So that's what that formula looks like. So there's all the equations. You can kind of look at that. So as we have these up here, it's not going to impact us to run regression. All right, so the first one, do buyers pay a premium for a brick house, all else being equal? So we're just going to look at brick, right? So we'll run, we really can't do much with brick here. But what is, to kind of set this up, if you're using stat tools, it doesn't really matter. But for the way that we need to set it up, we need to move our dependent variable over, right? So what things are we going to consider? Offers as the independent predictor, square foot, okay? Not brick, because we've already picked it up. We can't do anything with that, okay? Bedrooms. How about bathrooms? Yep, because it says all else being equal. And let's see here. Brick, yes. Price is going to be, that's our dependent variable. So that's what we're trying to predict, is price. Okay. And let's look at neighborhoods, which that's all else being equal as well. So here's where it kind of gets a little bit dicey, but not in a bad way. So we're going to move this over here, and we're going to cut these particular data points and insert them here. So now we've got our dependent variable one place. We have all of our independents lined up right here. Okay. We will get to these variables, but right now what we're concerned with is predicting price based on offers, square foot, bedroom, bathrooms. Does it have brick? Yes. And what neighborhoods? So let's do it. Data. Oops, not draw. Again, I'm just holding the shift control and arrow key and then going down. So what do we have going on? Okay, so as we're looking at our R square, 86 looks relatively strong, right? We've pulled in our offers. I didn't populate the residuals, which are the charts, to kind of glance at the data, but that's okay. Bedrooms, brick, and district, right? So what can we take away from this? If we look at our first question, do you pay a premium for a brick house? According to this, you do, right? So we've got significance here. So based on the intercept, it's 4,300, and so for a brick house, it's about 35,000 more. That's how you interpret this. So a 1 unit increase in a brick house is equivalent to about a $35,000 bump in price. Okay? So we can answer the first one. Is there a premium for a house in neighborhood 3, all else being equal? So we can kind of look here as well. And according to this, yeah. So by having a house in neighborhood 3, it's about a 41,000 increase as well. So that's where we can look at a variable on a single level. Obviously, if we remove one of the variables out of the equation, it's going to adjust these. But when we consider all else with brick, bathroom, square footage, offers, and whatnot, it plays a role on the value. Okay? All right. Number 3, we're going to have to run another regression for this one. It says, is there an extra premium for a brick house in neighborhood 3 in addition to the usual premium for a brick house? Okay. So let's go back to our data. And this is where we're going to incorporate brick house in neighborhood 3. Okay. That's good. And what we got to do is adjust this. We got to add the house and brick house. The brick house, excuse me, in neighborhood 3. Again, shift, arrow over, control down. We're going to do a new sheet. Okay. So is there a premium, as it asks in the question, in addition to the yes, right? So we can see it's about a $20,000 premium on top. So think about that a little bit. By being in with brick in this particular neighborhood, we've looked at the additional value, right? In the last one, it says, for purposes of estimation prediction, could neighborhoods 1 and 2 be collapsed into a single older neighborhood? We could do that. We don't have to adjust the DV. Let's think here. We're going to collapse 2 and 3. And what we want to look at is brick, yes, right? Neighborhood 3, yes. And brick. So let's take off this 2. We do this. Since we're collapsing. And what does this story tell us? Is there still a premium for a brick house? Yes. Right, so as we're looking at, for prediction purposes, we've collapsed 2 and 3, essentially. We've taken 2 out, but we've kind of integrated it and collapsed it. There's still a premium for a brick house in the neighborhood. So a lot of moving back and forth. If you're using stat tools, you don't have to move back and forth per se as much because you can just select your variables. But that's practice, adds to this. So hopefully you got some good stuff out of this. It kind of went long, but it's part of the lab. So I will catch you on Monday. Have a good evening.